Hello, I am Dhanikilal Sahni. I am 11x Salesforce Certified Application Architect and working as a Salesforce Architect at Wagwan Cloud Solution. Data modeling is very important for better performing Salesforce applications. In this video, I will cover data modeling in detail. This will be the first module for Salesforce Data Architect Certification. Here are the key takeaways from these videos. You will be able to understand what is data modeling, why it is that important, what are the types of data modeling, and then we'll see key component for the data modeling in a Salesforce. And at last, we will have few demo related to data modeling. What is data modeling? Data modeling is a fundamental aspect of Salesforce architecture that defines how data is structured, stored, and accessed within the Salesforce platform. As a Salesforce architect, mastering data modeling ensures that our solutions are scalable, efficient, and optimized for performance. If our data model is not scalable, then it will be performing slowly as data will grow year by year, and we will also do a lot of customization for business request. So why is data modeling important in Salesforce? Data modeling is a foundation for designing efficient, scalable, and high performing Salesforce implementation. It ensures that our data is structured logically, stored efficiently, and accessed seamlessly. It will enable better CRM functionality and business decision making. Let's see the first important point for the data modeling, which is ensure data consistency and integrity. A well structured data model enforces data accuracy and consistency across records by defining relationships, validation rules, and security settings. Salesforce ensures that data is not duplicated or inconsistent across objects. Field validation maintain data integrity like email format validation, age validation, and the master detail relationship will ensure the child records are dependent on the parent record. It also helps in better database design and the performance. Proper data modeling optimizes storage and retrieval process, leading to improved database performance. It ensures that efficient indexing for the faster retrieval of the data, normalized structure to avoid redundant data storage, sometimes denormalization where we need in the reporting and analytics also can be done. Denormalization is a database technique where we combine two tables or multiple tables to improve read performance. This way, multiple joins are not required to get the data. We query single table and we will get all the required information for our reporting or analytic purpose. We will cover this topic in the next video. The third and a very good decision making important point is it is structured data logically. A well designed data model ensures that data is structured in a way that it aligns with business process and reporting needs. It helps in generating meaningful reports and the dashboard for better insights. It supports AI and analytics for sales forecasting and customer trends and providing a 360-degree customer view by linking accounts, contacts, and the opportunity logically. The fourth very good important point for the data modeling is it simplifies data migration and the integration across system. When businesses migrate to Salesforce or integrate it with other applications, a well-defined data model ensures seamless transition and the connectivity. It helps in mapping data effectively from legacy system to Salesforce, reducing data transformation efforts by keeping structures intuitive, ensuring API compatibility for smooth integration with ERP, marketing, or financial system. Nowadays, integration is one of the important factors for getting 360-degree data in one place. Now we understand why that is so important. Let's see what are the types of data modeling we have. The first type of data model is a conceptual data model, which is a high-level overview of business entities and the relationship. This is basically to understand what data do we need. Then we have a logical data model, which defines relationship and attribute. Basically, this is a detailed representation of system data structure. It tells how is data structured. Then the last one is a physical data model, where it tells how data is stored in the database, like how we are creating tables, how much data will store in particular field. For those kind of information, we will have physical data model. Let's understand conceptual data model in a little bit more detail. A conceptual data model is a high-level representation of systems data structure, focusing on business entities and their relationship without technical details. It is designed for business stakeholders to understand data flow without database complexity. This is a platform independent data model, so no specific database related design is prepared in this kind of data model. If you see this data model, we have few entities like customers, orders, products, and the payment. And in this data model, we are just showing the flow, like customer places the orders, includes the product information, and order has a payment from the customer. So there is no data storage related information, no key related information mentioned here. So in that, the conceptual data model is no business, no indexes, other information is mentioned. In this data model, we do not include attributes, primary key, or storage detail. This model is for business analysts, product manager, and stakeholders, business stakeholders basically. Let us see how conceptual data model is used. The first one is business understanding. The conceptual data model is used to discuss with the business stakeholder who are not tech savvy. It helps align data needs with a business goal. The second one is early validation. It allows business stakeholders to refine data structure before implementation. Because when we discuss this data model with a business stakeholder, they can refine it. They can tell, okay, which process need modification. So all those modification can be taken care before the next process is started. Then we have this data model is foundation for the logical and physical model. Basically, it serves as a blueprint for the database designer for logical and the physical model. Then we have a logical data model. A logical data model is detailed representation of systems data structure. We define entities, attributes, primary key, and the relationship without focusing on physical storage. This model is also a technology independent and serves as a bridge between the conceptual data model and the physical data model. We specify primary key and a foreign key in this data model, and it can include attributes like a field information in the model. It normalizes the data, and also it's it's technology independent data model. If you see this data model, we have a few entities product, customer, order line, and date. And we have added the attributes in each entity. Like in product, we have product ID, product name, category. In customer, we have customer ID, customer name, state, and region. And we also specifying primary key and the foreign key information here. In this model, we list out property for each entity. To ensure uniqueness, we define indexes like a foreign key and a primary key, and we can also have a relationship. With the logical data model, we can visualize process workflow in technical structured manner. We can understand the relationship between various business systems. This model is for solution architect, data analyst, and the database designer. Let's see how logical data model will be used. It ensures data integrity as we do entity renormalization and create indexes with a well-defined relationship. It prevents duplicacy of the data. It also simplifies database design. This model will act as a blueprint for database implementation. Then it will prepare for the physical data model. This model will help determining indexing, partitioning, and the storage for the physical data model. Let's see the last data model type, which is physical data model. Physical data model is a detailed database specific representation of systems data structure. It defines how data will be stored, organized, and accessed within a specific database management system. Specific database management system like how the model will look like as a Salesforce specific, MySQL specific, Oracle, or PostgreSQL specific. The physical data model is built from the logical data model and focus on the actual implementation details like tables, columns, data type, indexes, constant, and storage mechanism. It is also optimized for the performance. You will see this data model, physical data model. We have few entities here: customer account, account type, purchase, bank services, service type. And if you see for each attribute, we are also specifying what kind of a data particular field will store and what are the size of particular field. Like customer name, I have varchar 60. So we are specifying the storage information as well. And we have uh, the relationship type as well, like one to many or many to many kind of information also available in this data model. Let's see why this physical data model is important. It helps in database implementation. It will help in creating tables, defining relationship, and structuring storage information. It is helping in data security and access control. We can define users permission, encryption, and the authentication as well in this kind of a data model. It will help in performance optimization, like we can use indexing, partitioning, and denormalization for the faster query execution. This model is for Salesforce developers, database administrator, so that they can create a specific data model in the database. Now we understand the types of data model. Let's see what are the core components of the Salesforce data model. In Salesforce, we have objects, fields, records, relationship, and record type. These are the core component. Apart from these core component, we have other component as well, like we have validation rules and formula fields, index and the performance optimization tools, custom metadata settings and types which we have, and then we can have external object as well. Now the other component like platform events, uh, CCD information, CCD object as well we have. So we can also treat them as a kind of data model, because when we do the database designing, we think how platform event can be used for creating a data flow right? So we can also treat them as a component, but as a core component, we can understand that we have a object, field, and the relationship are the core component. Let's see what are the objects. Objects are container for related information. Like we have customer, we have a opportunity, we have a product. So customer will hold information related to customer, and it cannot have information related to product or other thing. So it will container for the related information. Salesforce support different type of standard objects like standard object, custom object, external object, platform events, and the big objects. Let's see what are the types of object in a Salesforce. We have a standard Salesforce object, which is pre-built object for specific cloud, like for sales and service cloud. We have a lot of standard object like account, contact, lead, opportunity, and product. Custom object, basically we create to customize our functionality, like we can create insurer or the license for the insurance domain projects, right? Salesforce provide default page layout for each object. That is the beauty of this Salesforce applications, right? You don't need to create a page layout. It will automatically create a page layout for each objects, whether it's a custom or it's a standard object. Then we have another core component, Salesforce object field. Field stores specific type of information within an object. It is similar to columns in a database. We similar to object, we can have two types of field. One is standard field, basically, which is predefined field, which is created automatically by the system. Like we have a name field, we have a created by, created a, last modified, or last modified by. So these are the predefined field which is created automatically when we create custom objects. Then we have a custom field, basically that is user defined fields. Like we can create customer DOB or customer type on the account object, right? So we can create multiple fields based on our the business requirement. As we can create a different kind of field, it can hold a different kind of information as well, which we call as a data type. So we can have multiple data types in the Salesforce. So let's see few of them. We have address data type, which will store data related to the address, which can hold state level information, city, state, zip, okay, and the country related information in one single compound address field. Then we have calculated field, which we can say it's a formula fields. We have pick list, which is set of enumerated values, and it allows the user to specify a value which is in the list or not. Then we have currency, that we can set the currency values. We can have an email field to store the email related information. We can have auto number field, which will automatically generate the numbers on runtime when the record is created. Then we have roll-up summary field, which is, we can say, aggregated data field for the child in the parent object. Okay, so we can create multiple, like how many childs we have for particular account, right? So we can create a summary field for that kind of information. Then we have a checkbox, which is store the Boolean information, like customer is exist or not. So that kind of information we can have a checkbox field. Then we have a date to store date information, date and time to store date and time information, geolocation to store the geolocation, latitude and longitude information in the field. Then number to store any specific number type information, percent to store percentage number, phone number to store phone number. So no need to use text field here. We can use phone number data type itself to store the phone data. Then we have multi-pick list, where you want to store multiple pick list information. The text information to store combination of letter and numbers into up to 255 characters. Text area, similar to the text, only information change in the text area is it can hold multiple lines information. Text area long will hold information up to 1,31,072 characters in multiple lines. Text area rich basically store text area which can hold the information related to images. It can hold images, media, and the links as well. Text encryptor, where you want to store the encrypted information in the field, then we can use text encrypted. To store the time data, we can use time field, and then URL, like when you want to store the URL or the website address, then you can use URL field. Then the third core component which we have is a relationship. So relationship, basically we can say it's define how objects are connected to each other. In Salesforce, there are 3 or 4 kind of lookup relations or relationships available. The first is lookup relationship, which we can say is a loosely coupled relationship between two objects. So in this kind of relationship, child record can exist without the parent. So that's why this is called a loosely coupled. Like example, a contact can be associated with an account, but it can also exist independently. If an account is deleted, the contact record remains in a Salesforce. The contact can be linked to or removed from an account anytime. So association and deassociation both can be possible in a lookup relationship. The second type of relationship which we have, master detail relationship, which is a strongly typed couple information. So in this, child record depends on the parent record. Child record cannot be created without the parent record. So take an example, we have opportunity product can be linked to opportunity. Opportunity product is not cannot be created without the any opportunity. And if the opportunity is deleted, all related opportunity products are automatically deleted. So we can say this is a case card delete relationship. Child records inherit the security setting of the parent. So if anyone has access to the parent record, by default they can get access to the child record. Then we have a many-to-many relationship where we use allow relationship from one object to be associated with multiple records from the another object. So by default, Salesforce doesn't provide you a many-to-many relationship, but as a workaround, we can use junction object in to create a many-to-many relationship. So junction object we will handle, or we will take a session in probably in the future. So we'll go in detail for the junction object in another video. So there is another lookup relationship, which is external lookup relationship. When we create external objects in a Salesforce, to create a lookup relationship, we can use external lookup relationship. So we covered theoretical part of the data modeling. Let's see how we will do the data modeling. Take an example, you as a Salesforce architect, as a Salesforce data architect, you got a use case or you business requirement that a company want to track customer type for each account in Salesforce. This will help categorizing accounts into different segments such as enterprise, small business, and partner. So you need to create a data model for that. So how you will do that? So in this case, we can add a new field, customer type, to the account object. This field should be a pick list with the values enterprise, small business, and the partner uh, options. The field can be marked as a mandatory for a new account, and sales representative should be able to filter report based on the customer price. So we can create that kind of information. So let's see how we can create that in a database. So let me go to, this is a Salesforce or which I have created newly. So go to the setup. Then we will go to the object manager. we have account object. So in account object, we need to create a new customer type field, which will hold data related to custom type. So classic view will create, as we said, it's a pick list field. So we'll go and create a pick list. Put customer type. Then we can create options here. Enterprise, small business, and then partner. And we can also choose validation. Always require a value in this field in order to save, because so we are making this field as a mandatory as well. Now next, so in which kind of profile this field should be available, you can select based on that. For right now, I'm just making them available to all the profile. Then this field is available in this layout. So based on all fallout, so we are saving it now, and that's it. Now that field customer type is created, right? Let's see the other use case here, where we will define a new data model design. Use case is a company wants to track training in program provided to its partner accounts and employees who attend these programs. This will require a custom object creation, right? For this use case, we can have 3-4 objects, like standard object account can be represent as a partner companies. Then we can have a training program object, which will hold information related to name, training date, training type, instructor, so basically who will do training, then what are the duration of the particular training, what are the status of that particular training, and for which partner company this training is being organized. Then we can have an employee object, which will hold information related to name, email, phone, job title, and then employer, basically who is the employer for the particular current employee. And then we have a third object, which is training enrollment. So basically, when this particular training is done, enrollment date and completion status, score, and then we will have two master detail relationship, training program and the employee, because this particular object will be treated as a junction object. And why this is because basically for particular company, multiple employee can be there, and those multiple employees can do the multiple training. So for that kind of a situation, we have to go with a junction object, right? So you will see, so this could be a conceptual data model for particular this use case, where company has employees which they can enroll to training program using training enrollment object, right? So this can be a conceptual data model. Then we can have a logical data model, where we represent account as a company information, employee who has employee related data. Then employee can have a training enrollment, and that enrollment will have a training program. They can hold a training program, right? So this can be a logical data model. And in physical data model, for each property, we are storing the type of data that can store and how that is associated with one object to other object. So this kind of data model we can create for particular use case, right? And similarly, we can create data model in our Salesforce. Similar to the I have created one customer type, you can create a data object in your Salesforce. So if you found any issue while creating any field or object in when you are doing the demo, or when basically you're you're doing the code or the development, you can ping me. I can probably help you in that scenario. Then another important component for the data modeling is record type. Record types allow different business process for the same object. Take example, you want to store patient, hospital, and doctor information in the same object. Okay, then in that case, we can use record type to differentiate type of record, right? Like record type is a patient, that particular record will be of patient record. If we store the record type as a hospital, then it will store the hospital information. So based on the record type, we can have a different UI, which basically can say different page layout we will adding for these record type. So this you can also think the record type is a part of data modeling, because you are not creating different object to store different objects, right? Right. We are just using the same object with the record type we are storing in the same object, right? So we can say record type is also a component for the data modeling. So let's see summary for that this video. Data modeling is a building blocks for the database design. Conceptual, logical, and physical data modeling are the types of data modeling. And then we have a Salesforce using object field relationship for the modeling of the data. We'll in next video we'll understand schema builder, how we can use schema builder to basically to create these data model through the UI way, instead of going to the object manager and creating a fields or modify the changes of that data model. We can use schema builder to create a data model, right? So we'll see that in the next video of the data model. Till now, thank you for listening. Thank you very much.